So this is a sample of some of the machines that have been handed in 2019, or parts of early iterations. This one here is quite a simple machine. We see that we've got some permanent magnets here. The current, when it's turned on, will come in through the commutator, energize one of these coils and back out to the thing. And then one of the coil that's energized, it will be repelled or attracted around to the appropriate one. And this works quite well. We can turn it on, give it a bit of a tap. You can see it going there. Now, I don't know if it's going to come up on the video or not, but there's some sparking that's going on in here at the commutator. I've got some others that do a far better job of sparking. Part of the reason for that sparking, here it is what I've talked about in the previous video around building these things and around the one wire on there. That's the video that I've just finished filming actually, and it'll be going up around ideas for hobbyists in building motors and what to watch in this commutator video. So that was one of them. This one here was another one that was built. What we see here is a 9-volt cell that's connected, that comes in, it energizes a coil that is underneath this Coke can. So we see the current coming in through the red wire, energizes the coil, and then it comes up through here, and the current is broken by this single wiper on it's effectively a commutator. And so in this condition here, the current's broken, and here it's connected, here it's broken, and here it's connected, and here it's broken. So that enables the coil to be only energized when one of the magnets is in the appropriate place, not directly lined up over it. And this works reasonably well. And again, we see a little bit of sparking going on down here. You can see a bit of sparking just there. Another machine that was made that will be shown, I'll append it on the end of this because I haven't got the controller to get it going, is this brushless DC motor here, which has been 3D printed to hold it. It's used a bolt to create the core of the pole with the windings around it. These 3 windings have been configured in star. There's your three windings there, and then effectively your neutral wire. And when that is energized, you turn one of them on, it interacts with the permanent magnet on the rotor, which can then pull that around to that position there. It will turn that one off and pull on the next one, maybe this one over here. It will then attract to that point there, and as I said, this will be shown as part of this video, but I'm not talking about it right here because it's a separate video clip that I need to edit in. This machine here is an Axial flux machine. We can see that we've got a series of coils which have been embedded in resin on this rotating platform. In the bottom underneath here, there is a series of permanent magnets which have been installed in here. The coils are energized through this fairly large commutator, and this thing works very well. It's slightly unbalanced, so it vibrates a little bit, and you'll see some definite sparking on these commutators. There we go in there. And you won't be able to pick it up on the video, but you can smell that ozone. Another machine which was built is this one here, and this is a brushless DC machine. You can see it's been built out of some PVC piping, and we've got a wooden shaft which has been run on a couple of bearings here, and it's energized on the outside with our various windings around here. We open it up, you can see in through there we've got our shaft, some permanent magnets attached to it, and each of these windings has a inner core which is made out of a bolt, and if you look inside there you can see the bolt head. This machine adequately shows the issues around air gap. When we pull it down here like this, the magnets are being attracted to the metallic core. I think that's why we need the bearings at each end. If I lift it up out of the way, then that ceases to be a problem. This machine worked wonderfully.
Wait, is it on?
Someone else made a brushless motor.
Here you go, sir. It's
That's the
moving.
original idea I had.
Sir. Got it.
That's exactly that kind of
Keep going.
No, I'm just recording this shit.
I use the car one.
Because brushless motors are so much cooler than these.